Alrighty, so today we are going to be talking about concentrations of solutions. So, um, many people have a qualitative idea of what is meant by concentration. Now, anyone who's made instant coffee, lemonade, even Kool-Aid knows that too much powder gives a stronger flavor, gives a strongly flavored, highly concentrated drink. Whereas too little results in a dilute solution that may be hard to distinguish from water. You know, the word, it's too watery, you need to put more into it. In chemistry, though, the concentration of a solution is the quantity of a solute. Remember, solute is what is being dissolved, like salt and salt water, sugar and sugar water, that is contained in a particular quantity of solvent. Remember, solvent is that medium of dissolving, so the water, it's usually water or solution. Knowing the concentration of solutes is important in controlling the stoichiometry of reactants for solution reactions. So figuring out how much of each we need if we want to get this certain concentration. The most common unit of concentration is molarity, which is also the most useful for calculations involving the stoichiometry of reactions in solutions. So the molarity, and we symbolize molarity with the capital M, that's also going to be the unit for molarity as well, is defined as the number of moles of solute present in exactly 1 liter of solution. So here's the equation. We got molarity equals when you take moles divided by the liters of solution. So meaning it's just moles divided by liters. So more with the variables, it's N, since N is represents moles, divided by V, which is volume, equals M molarity. And the unit for for N is moles, obviously. The unit for volume is going to be liters, like always. And the unit for M for molarity is M. So now we're going to do 3 examples together. Alrighty, so let's go ahead and do 3 examples of calculating either concentration, moles, or liters using the molarity equation. But first, I want to show you this. I have a triangle. You probably have seen this before with the density equation. We have moles, volume, and molarity. So let's say the problem is asking us to find moles. All you do with this triangle is you cover up moles, and it's telling you that you're going to multiply molarity times volume. You can do the same thing. Let's say the problem is saying we need to find volume. You cover up the volume. It's telling you telling you to take the number of moles divided by molarity. That's pretty much how you use this triangle. So we will be revisiting this triangle for each problem we're going to do. So our first problem we have is, what is the molarity of a solution containing 4.0 moles of solute and 25 liters of solution? So we are given our 9.0 moles, and we're given 25 liters. And we are trying to find the molarity. That's what we're trying to find. So let's go ahead and list out our variables that we know of. So we know our N equals our 9.0 moles. Our V, which is our volume, equals the 25 liters, but we don't know our molarity, so we're going to have M as a question mark. Okay, so we're trying to find molarity. So revisiting the triangle again, we're going to cover up molarity. It tells me we're going to do moles divided by volume. So the equation we're going to be using is, we got N divided by V. So let's just go ahead and plug that in. N is our 9.0 divided by our volume, which is 25. And when we solve for that, plugging that into our calculator,
we get 0.36 molarity. The unit for molarity is capital M. That is how you do that first problem. All right, so let's move on to our second problem. Our second problem is, what is the number of moles of solute in a 0.65 liters of a 0.40 molarity solution? So what we're given is 0.65 liters, 0.44 molarity, and we're trying to find moles. So let's just go ahead and list out our variables that we know of. We don't know our moles, so our moles is going to be a question mark. Our volume is the 0.65 liters, and our molarity is 0.40 molarity. So we got to find moles. So we're going back to our triangle. We need to find N. So we're going to cover N, and it tells me we're going to do molarity times the volume. So the equation we're going to be using is N equals molarity times volume. So just go ahead and plug in our numbers. We have molarity is 0.40 times the 0.65, and plugging that into your calculator, we get 0.26. Remember, the unit for N is moles. Okay. All right, let's do our last example. How many liters of a 0.30 molarity solution are needed to give 2.7 moles of solute? So, we are given molarity, we're given moles, we're trying to find liters. So let's go ahead and list out all our variables. We know our moles equals the 2.7 moles. Our volume, we don't know this time. We need to find our volume. So it's a question mark. And our molarity is a 0.36 M. So referring back to our triangle, cover up V since we need to find volume. So that tells me we're going to take moles divided by molarity. So the equation we're going to use is V equals moles divided by molarity. So plugging in our numbers that we know, we have 2.7 divided by our 0.30. Plugging that into our calculator, we get 9, and we know our unit for volume is going to be liters. And that's your answer. That is all you do.
Alrighty, so that's all I have for today. Homework has been posted on Google Classroom. If you have any questions, let me know.